Hello friends, welcome to today's episode of Problem of the Day series from Leetcode. Today we are going to solve the problem 1312 minimum insertion steps to make a string palindrome. The problem simply says that I had been given a string s, and in one step I can insert any character at any index of the string and find out the minimum number of steps to make a string as such a palindrome. So for example, I have been given this string. So if you can take a look that this string is already actually a palindrome. So I don't have to make any changes. So that means that number of steps required is actually 0. Second example here is MBADM. So let's take a look. So MBADM. So we can see that this character and this character, they are same, so there is not much work here. So now we have reached to this position. At this moment we have to make them palindrome. So there are two options I can have. First, I can insert D over here, so that will make you D B A D. I am skipping this character to make things simple, right, to make them palindrome. Or I can take B and insert here. So that will make me B A D B. So now we have palindrome. So now we can do the same process again on these two substring. So we can say this is a string, this is a string. So we have to work only on these two. And these are the two strings. So only thing I have to do is insert one character here and make it a palindrome. Similarly, we can do here. So if we look at the algorithm point of view, what I am thinking, that if I have been given this string, right, so we have a start and we have the end. So as long as they are same, that means it's possible to already a palindrome. So we'll move to the next one. If this and this are also same, so let's make it x and x, and this is y and y. So we'll move to the next. And once they are not same, that is a and b, we are going to call the same function recursively, making them same. That means that we are going to make one move, plus next I am going to solve the problem from here to here, and the other one is from here to here, right? So basically when you did is that we made b here, we moved to b this position. So that means that this has already been taken care of, so I have to solve the problem for this. And when we move to this side, we have solved the problem here, solve this, so we are going to work on this. So this is we are going to do recursive way. So let's code it. So in recursion, what we are going to do is that we are going to create a helper function. We are going to create the same. The only difference would be that the helper function is going to take index of start and end to see that, and this function is going to return that how many, or we can say what is the minimum number of insertion needed to make the string s starting from start to end to make it a palindrome, right? So that means that in my main function I'm going to return minimum insertion s comma I need from 0 to s dot length minus 1, right? uh, Now in this, so we are going to simply start with our while loop looking at the end of the characters, just like here and here. So while start is less than or equal to end, and if let's make it str, start is equal to str of end. That means that possibility of palindromes, plus plus start minus minus end and continue, right? And at any moment when we say that they are different, so we'll just break. Now if I look at the algorithm, that means that now we reach to this situation where they are different. So now what we are going to do is, okay, also we have to check if they are palindrome, right? So if start is greater than or equal to end, that means that it's actually already a palindrome, so you return 0. So first option, integer count 1 is equal to tr this one, that is saying start to end minus 1, is from start to end minus 1. And for the second option, will be our start plus 1 to end, right? And then since we are already making the change, so there will be at least one move we are making here. So we are going to return 1 plus minimum of these operations, count 1 comma count 2. So this works fine for a small range of string, but it will definitely really for longer, because at any moment we are making two decisions, so it will be having a polynomial complexity. So, and also if you look at this code, right, we are having an overlapping sub problems. So that means that we can solve, that means that we are calculating same problem again and again. So let's cache the result in between, and we will use the result to avoid unnecessary calculation. So we are going to create a memo. So I'm going to create a private memo, and then we are going to initialize the length of, it's a two dimension, okay, sorry. So we are going to, it's a two dimension arrow, two dimension matrix, because in this equation we have the two different variables, right, start and end. So that is the reason we are creating two dimension matrix. So let's initialize it. The row and column size for this memoization will be s dot length, right? And then we will initialize it with -1, just to ensure that we haven't, if the value is -1, that means that we have not calculated the result for that. Now simple here, if memo of start comma end is not equal to -1, we are going to return memo of start end. Otherwise we are going to store this result in my memo, and we will return the result. Sounds good? Now we can solve the same problem using dynamic programming with the bottom-up approach. So suppose that we have a string, okay, and we discussed with the memo, right? We already seen the memoized solution. That means that now we are creating the same matrix but in the start, right? Now the question here is that suppose that we call it like dp. So what a dp of I comma j means, so or it represents, so dp of ij represents that the number of what is the minimum number of insertion needed to make the string from I to j to be palindrome. That is what dp of ij represents. So that means that our result is going to be represented as dp of 0 comma s dot length minus 1. Okay, so so this is going to be our result. Now if we have this string and we go with a bottom approach, so consider this case where, for example, that if you have only string which is only one character long, that means its length is 1, what is the minimum number of operations required to make this string as a palindrome, which is actually 0. Why? Because it's already a palindrome. What does it mean? That means that dp of I comma I is, so string starting from index I and ending at I requires how many insertions? 0. So this is for a string of length 1. Now another one is, what is about the length of equal to 2? So for length of 2, that means that, so suppose this is the string. So if string of I, str of I is equal to str of I plus 1, that means that it's already a palindrome. So that means this dp of I comma I plus 1 is equal to 0. Alright, now let's take a look of general scenarios. So here, in other cases, from suppose my I is here and this is j. So now in this case, so if my this character is same as this character, that is if str of I is equal to str of j, right? So that means they are same, and that means that dp of I comma j is going to be same as this value, because we know that what is the minimum number of insertion required to make this palindrome, and they're already same, so it is going to be the same value. So that means dp of ij is equal to dp of I plus 1 comma j minus 1. Otherwise, else that means that now we are going to make a changes, right? We are going to make one insertion. So one insertion means that you're going to add 1 plus, same case where if I am inserting this character to here, that means that now I am solving this from start to n minus 1, start to n minus 1, and if I am inserting this to here, I am solving from start to n plus 1. So that means that this is actually going to dp of I plus 1 comma j and dp of I comma j minus 1, and we will take the minimum of this. Now let's code it. Memoization dp n is equal to your str length and size is going to be n plus 1, The n plus 1 I am taking it because you could be having an empty string, and that will make the length of the string could be empty plus n, the total n plus 1. And initializing with mint.mix value because we need a minimum number of insertion. And then as we discussed that we are going to treat the string of length 1. So basically what I'm doing is that I am traversing this string I is equal to 0 less than n, and for dp of I is equal to 0. Alright, now for the length of 2, it's the same. If str of I is equal to str of I plus 1, dp of I comma I plus 1 is equal to 0. So we consider length 1 and n2. Now let's work on the general code we have is for integer I is equal to n minus 2, I greater than or equal to 0, minus minus I, and then for integer j is equal to I plus 1, j is less than n plus j. Right, now if I is equal to j, or you can say if dp of it's already been calculated, right, dp of I of j is equal to 0, then continue. Otherwise, now if my str at I is equal to str of j, right, so in this case we saw that if they are same, that means dp of I j is equal to dp of I plus 1 j minus 1. Else it is going to be 1 plus the minimum of the two options, and we are going to return dp of 0 comma and minus 1. Alright. Alright, that's good. That's all for today. And if you like this video, please like it and subscribe to our channel. Thank you very much. See you tomorrow.